Okay, so in this package, yesterday I asked you to work on, we went through all of this stuff yesterday, and we looked at these steps, which are long and arduous because they're notes. But if we cut to the chase, and we go to our questions, do you know what arduous means? Burdensome, tedious. If we go to our notes, I asked you to do this question for homework. Okay, so the first thing you're supposed to do is what? What's the first step that you're supposed to do? No, what's the first thing in all these questions? List species. Why do we say this fancy word species? Why do I bother?
It's what's in it.
It's what, sorry?
It's like what's in it.
Yep, but why do I use the fancy word species? Why don't I say atom? Okay, so species is the chemistry way of saying atom or ion or compound or molecule or, because I don't want to commit to saying one thing. If I say ions and all of a sudden there's no ion, okay, so when you come across the word species or particle in chemistry, it's just, you know, you can replace it with thing, the thing, list the things here. Okay, because I don't want to commit to saying specifically we're talking about ions, because we're not. We're just talking about all of them. Okay, so list the things here, one, and then number two, what do we do after you've listed all the species?
Find the strongest oxidizing agent and reducing agent.
Okay, so find your strongest oxidizing agent and your strongest reducing agent using the data booklet. And then the third thing we do is, after you do that, you write your half reactions. Where do you find those?
In your data booklet?
From the data booklet. And number four, what do you do after the half reactions? Amanda.
Balance.
Balance what?
The charges.
Nope. After you've written the half reactions from the data booklet,
Yeah.
what's your next step?
Balance the half reactions. Electrons.
Balance the electrons. And then number four, you write your net reaction. And number six, then this is where you were, Amanda. Number six is we just check. Check that it's balanced with science 10. Check that our charges are balanced overall. Okay? Simple. I forgot. Spontaneous or not.
Spontaneity.
Okay? So actually, you know, this sort of thing we were doing at the beginning of the chapter already. This was the beginning of yesterday. So what makes this difficult is it's all of it put together and the use of the data booklet. But please don't think it's another thing. I have to learn something else now. Actually, it's just an accumulation of everything you've learned.
Net is actually from Chem 20.
And yeah, that's right. Net is actually from Chem 20. In terms of the definition that the spectator ions are all gone. Right? Liam, you don't have a package, do you?
No.
Did you check on Moodle?
What's that?
Did you check on Moodle?
No.
It's disappointing.
You're telling me I wasted my time loading everything up on Moodle last night? Is that what you're trying to say to me?
No.
There's a package.
Thank you.
Okay, what's present here? Potassium metal.
K solid.
K solid. Good. Now K ion is added to some water, so the other species present is H2O. Pretty simple. That's why I gave it to you for homework.
I like it.
Okay, so then you go to your data booklet. Hold on.
Find the formulas.
All right.
What? Do we have to charge the water?
You go to your Chem 30 data booklet and you try to find your
You can't talk.
potassium and your water. Please bear with Liam. Right, where's your potassium? So, you need to find your strongest. Liam, have you? Right.
I got it.
You got them?
I got it.
Okay, so down here, Liam, are the, what everybody?
Metal.
Strongest reducing agents
And
and the metals.
And then
Because metals are reducing agents. And then the strength goes from the
bottom to
bottom to the
top.
top, where
Gets
all of those
weaker.
are your
Weaker
at the very
agents.
top weak reducing agents. And Liam, yesterday I told everybody to just write it in your data booklet.
Yeah.
So you can use it as a crutch now. You
Right.
won't have it for a major test, a unit test, a chapter test. You won't have it for the diploma, but while we're learning it, we kind of need it.
Right.
Okay, so strongest reducing agent at the bottom and weakest reducing agent at the top. And on the other side, I have my strongest, top left-hand corner, strongest oxidizing agents down to your weakest. And you can just have a look at James's there, the weakest reducing agent
I'd write notes.
is
and you
lithium
can
1
get
plus on our data booklet. Okay, so I need, the goal, number 2 says, to find my strongest oxidizing agent and my strongest reducing agent. So in order for efficiency, I'm going to go down to the bottom where the strongest are, and I'm going to work my way up until I find one of the species I have listed. So potassium or water are the only species I've got here. So, right there, right away. So potassium must be my strongest reducing agent, so I'm going to write down strongest reducing agent there. And I'm going to write the half reaction, and this is weird, Liam, because see these arrows? This means I can read it in that direction. Exactly like last unit we did formation, decomposition, photosynthesis, cellular respiration. Doing the same thing here. It can gain an electron or it can lose an electron. So I'm writing this down backwards but forwards. Right. K solid goes to 1 E minus plus a K plus. And I've written that on my question booklet now. You okay with that? And then, just go, where's my board? There. And then I've got to look from the top right-hand corner where my strongest oxidizing agents are, here, and I'm working my way down until I find one of the species I have. So actually water is not near the top, so you've got to work your way down quite far until you get here. So water ends up being your strongest oxidizing agent, and I write that reaction down.
So it's not as
2 waters plus 2 electrons yields hydrogen gas and 2 hydroxide ions. Are we okay with that?
Yeah.
Okay. So back to my question booklet. Okay. So now I've got these 2 half reactions. So I've listed my species, I found my strongest, I wrote down those half reactions. Now I am, how many people got this far?
That's all. Yeah.
That's all you've got?
Yeah,
It's just
I messed up, like, I couldn't get it after that, I wasn't too sure.
Okay, so now what do we do? Now we're back to last week.
balance, like Hess's laws.
I used that now.
Last week wasn't Hess's Law, last week was the beginning of this stuff. We didn't have anything with water, but we certainly had that sort of thing, right? So what did we do when we had the 2 half reactions? We had to make sure that the electrons were balanced. Because if this guy is giving away 1 donut and this guy is taking in 2 donuts,
That's unfair.
that doesn't make sense. If in your story somebody took in 2 donuts, you must have had 2 being given out by the cafeteria, right? So how many times does the cafeteria give a donut out? Twice. So this must have happened twice. In order for 2 electrons to be given, so that 2 electrons could be taken. Hi. So we balance the electrons, they're there. We then write the net. So the net reaction ends up being, oh wait, remember I said to pause before you balance the electrons? And just make sure I've got electrons on both sides. That's where we paused last week. You should have an electron lost and an electron gain. Okay, so 1 on this side of there, 1 on that side of there, presto. So now I write my net reaction, 2 K solids plus 2 waters, the electrons cancel out, H2 gas, 2 hydroxide ions, and 2 potassiums. Ions. Gas, aqueous, liquid. Anybody get that far? Good, 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 good. And then with that little help, you got that far by the end? Okay. And then we check. What do we check for? Science 10. 2 potassiums, 2 potassiums. 4 hydrogens, 4 hydrogens, 2 oxygens, 2 oxygens, great.
You can check like
And then this new thing is checking our charges.
charges.
Neutral, neutral, so the left-hand side of the arrow is neutral. On the right-hand side of the arrow, neutral, 2 negatives and 2 positives
Cancel them.
make this side neutral as well.
Alright.
So that's good. If you've done it right, that should work out for you. You shouldn't have to do anything extra. If you find that they're not balanced, like this side was neutral and this side ended up being -1, it means that you forgot to take that 2 all the way through, because that's quite a common mistake to make. So it's just a double check to make sure you remembered all the steps properly and you did everything.
Spontaneity.
Everybody okay with that? Okay, so let's try number 5 together then.
We didn't do spontaneity.
Oh, spontaneity. Was it spontaneous?
No, it's spontaneous.
Yeah.
It was
Like,
spontaneous. Spontaneous because in your data booklet, the water was here. Here, there are the arrows, right? And the potassium was down here.
goes down the water.
So you read from left to right when you were talking about the waterfall, or this column is higher than that column. And so the water goes down. Therefore, spontaneous. I taught all of you Chem 20. Do you not remember me checking potassium in some water? I chuck sodium in the water and it forms a sphere and it sizzles around the top of the water from all the hydrogens being released. Remember that?
Yeah.
I chuck potassium in the water and you get a lilac flame. And it also sizzles around the water, top of the water. Bursts, the hydrogen ignites, and you get a lilac flame. Remember that? Was it spontaneous? Absolutely. What do you know about group 1 metals? They're reactive with water. Because they're all underneath the water in the spontaneity rule. Okay? Happy? Okay, so let's try number 5. So, what's present? Because number 5 is a little trickier. What do I write down?
Fe.
Fe. Can I make
Is
that
it
go
Fe
away?
like 3 plus or just
Okay, that's a really good misunderstanding. What's the difference between Fe and Fe3+?
3 plus is an ion.
3 plus is an ion, and so if I was saying I'm reacting an ion, I'd have to tell you the anion.
Okay.
Like iron 3 chloride, iron 3 sulfate. Then you know it's iron 3 plus.
Alright.
Iron bolt, as in like, you know, nuts and bolts,
Yeah.
bolt.
It's just gonna be iron.
Just iron,
Solid.
just Fe, just metal. Okay?
Yeah.
It's a fundamental difference, a fundamental understanding that if you buried your head in the sand in Science 10 and never sorted out the difference between an atom and an ion,
Yeah.
and I wasn't able to convince you it was important in Chem 20, you're now, suffering from that, paying the price. It's exposed to air, so what's in air?
CO2.
O2, which is the most significant reactive thing. So that's the second most common. What's the first most common thing in air? Thank you very much. Nitrogen. It's like 78% nitrogen, 21% oxygen. And then the third most prevalent?
Trace gases.
Yep, but which trace gas is the third most prevalent? This is like a good Jeopardy question. Huh? Argon.
Oh, I would have.
Wow.
Did you say argon? Good job.
I would have.
Okay, argon is the third most prevalent. But what do you know about argon? It's non-reactive because it's a noble gas. So that's probably not going to play a part in our species. But it's good to know that. And water, H2O. Nitrogen is also pretty unreactive. But you know oxygen is reactive, right? All those combustion reactions. So chances are you're looking at the oxygen in the air.
Oh, you're choosing it.
I'm not choosing it ahead of time. Just in my head, I'm going, I bet it'll be oxygen. And then I kind of am looking for it, right? Okay, so we've got those species listed. You then go to your data booklet and start at the bottom right-hand corner or the top left-hand corner, doesn't really matter. And you're looking for these things. And what do you see first? iron. So I'm going to write that down as my strongest reducing agent is iron going to iron 2 plus 2 electrons. Okay,
It's oxygen starting.
Then, what do I do next, Liam?
You look for your oxidizing agent?
Yep, so I start at the top left and I work my way down, trying to find one of these species in here. No. Well, there's oxygen, right? Except for what? What do we need to teach Liam, Josh?
You don't have iron.
I don't have any H+. I've got water, but that's not the same thing as H+. Okay? So I can't use that one. Keep going. Still can't, oh, sorry.
That's the same one, yeah.
I missed my board. Okay. So keep going.
Yeah.
Going.
Oh, two. No, you can't use it.
No, can't use that one.
Yeah.
Oh, look at this one. Oxygen and water. Can I use that one?
Yeah.
Is that higher than water by itself? Right? If you find water by itself, it's further down there, right?
Yeah.
So this is a stronger
Oxide.
team than the water by itself.
So,
So we write this one down. Does that make sense?
are nitrogen and argon like done?
Well, they didn't come ahead.
Okay.
So I don't even need to bother looking for them.
Alright.
It would be a waste of my time to find them all on here and circle them all and then still end up choosing this one anyway. Okay? If the question was, which of these species could possibly act as an oxidizing agent, then I want to go all the way down my list and find all of them. But that's not the question. The question is, which one will react, the strongest one. Okay, so strongest oxidizing agent, O2 plus 2 H2Os plus 4 E minuses, go to 4 OH minuses. Okay? Happy?
Yeah.
Do I have electrons on the left and electrons on the right, giving and taking?
Yeah.
Okay, so I've written them down correctly because it's, sometimes students make a mistake not writing the direction. They do it both as right.
It's not balanced.
It's not balanced. So number 4 says balance the electrons. So we're supposed to do, looking for another color, but I don't have one. There's blue. What do I need to do to balance the electrons, James?
You have balance the electrons.
Yeah.
So you got we going iron first, you gotta times it by 2.
Okay, so 2, 2, 4. Now my electrons balance. So I have 4 given out and 4 taken in. Perfect. And now I write my net. So here I have 2 Fe's plus an O2 plus 2 waters goes to 2 iron 2 pluses and 4 OH minuses.
Let me check.
Okay, check. 2 irons, 2 irons.
Yeah.
2 oxygens, so 4 oxygens, 4 oxygens, 4 hydrogens, 4 hydrogens. Neutral,
Neutral.
4 positive, 4 negative, neutral.
Okay. And then it's spontaneous.
Spontaneity, it indeed is spontaneous. It's called rust.
The more you practice it, the easier it is. Right?
Yeah,
Just the more you do it.
that's welcome to
Okay.
life.
Well, no, because yesterday I didn't get it at all.
Okay, by the way, so these 2
Go to my key
species
booklet.
will be formed, but can you see that makes an ionic compound?
It's so gross.
Yes? And so normally in Science 10, we wouldn't have written that. We would have written this. Fe 2 plus and an OH minus come together to make FeOH2. Did you see that?
Yeah.
And I will have 2 of them. 4 OH minuses in total. Do you see how that's the same thing? Okay? Not very often do I ask you to do it that way, but quite often they ask you to, they'll say that that's formed, like in the typing, they'll say, and iron 2 hydroxide is formed, and you have to know that that is the same thing. So don't be thrown off by that. Does that make sense?
Yeah.
Can you see that they're the same thing? And in fact, if you look up in your solubility table, you'll find that iron hydroxide isn't soluble at all. So actually these aqueous ions wouldn't be aqueous, they'd form a precipitate. And you know rust doesn't dissolve in water, you know that. So what have you formed? Rust, solid, not aqueous ions. Okay? Okay, so today's class, we are literally just going to work through these questions. 6, 7, 8. Then this is, do you remember this? Is a bit of practice about set up a table of relative strengths, oxidizing and reducing agents. Do you remember? Okay, so this is the table. And by table, I want your strongest reducing agent down there to the weakest reducing agent, and your strongest oxidizing agent here, and your weakest oxidizing agent there. Okay? I know this is throwing you off because you're like, whoa, I was ready to go and now it's a whole new thing. This is page 1 of that package. Okay, so let's worry about the other questions first, but know that we are moving on to some tables as well. Happy days? Okay, begin.
For tables, wouldn't